Good morning, everyone. Welcome to Dr. Harris channel. We are going to be talking, I am going to be talking very briefly about our next step. So our last time together, we had a mini movie of active transport and a very small introduction of some of the organelles within the cell. I believe it was the nucleus. We mentioned nucleus, we mentioned lysosome, and Golgi apparatus. I believe those are the three that were briefly introduced, gave a simplified function, and the very simple but effective because it's exactly what they do. I don't want you to think it was watered down or not precise as in what they do. It is what they do in a very understandable fashion so that you get it the first time, and then through repeat viewings and or discussions, it will become a part of just what you know in regards to the cell. I was really I keep looking to just hurry up and get to the signaling pathway because I so enjoy it. It's so wonderful. It shows you so many things, how the cascades happen and what that means, how we experience what's happening in our bodies. I think it's fantastic. I think it's great. I think it's exciting. However, that doesn't mean it's going to translate as something and lovely. So we're going to go and have a review of this, or an introduction, if you're not already aware of the cell, the organelles in the cell, and their function as it pertains to signaling, because that's what we're here for. We're here to discuss the signaling ultimately, and then go through the maladies. Right, so remember in our very first video, after the intro, we were supposed to be talking about diabetes type 2. Or just diabetes. I just said diabetes, I believe. I have the book. I wrote everything down so I had no follow-up to make sure it's seamless, the understanding. This is priceless. Be able to understand it, get it, hold it, own it, and then use it. That's the purpose of the channel. So let's keep in that vein. We're going to get an introduction or a review of the cell and the organelles in the cell, and the concentration is going to be on those organelles that are going to take us into our signaling transductions. That's it. We're not going to ignore anyone. I'm sure we'll touch on everyone because I tend to be thorough in this regard with this, because again, seamless understanding, that's the foundation to build upon. So you're going to see these things. This should be coming hopefully by next week. I've commissioned someone to put together my talking cell. It should be cute. It's like a cartoon, so it's not too boring, and it gives a different dimension. It still is going to be realistic with the things that you're actually going to find in the cell if you were to open up your arm and just pull, or open up some piece of, or have a cut and pull out the cell to see this cell. It's going to be that. And then we can then start to go into the wonderful world of the signaling transactions that happen. It's going to be a cascading of biochemical events within the cell that allows the cell to know what to do, how to do it, depending on the feedback. It's like having a conversation with a person, and the conversation is good, and everybody starts gravitating towards your conversation and getting involved and you're eliciting responses, and you're asking questions, and questions are actually being answered, and the conversation just grows and gains momentum, and it becomes a group discussion. I don't know how many of you have had that happen either at a party or at a social event or at your dinner table or at holiday events with a bunch of people, and one person is talking and then it becomes a table discussion, and it's well. Even if some of the things within the topic itself, it's like, ugh. It's exactly the same way as having a conversation that starts off between two people and then starts to include other people, and it comes together to bring this massive collaboration of events that happen. It's just like that. with some scientific and organelles that we're going to get be introduced to, like the mitochondria. it's a it's a key in signaling. It talks to the cell. It lets the cell know, how it's doing. In addition to signaling, okay, this needs to happen, that needs to happen. We're going to talk about. We talked about lysosomes. Probably going to hit that again because it's important in the cell signaling. Just the same way as active transport is important, because that's the very first step into this conversation. So backpedaling, the active transport is the very first step, because you have to do the lock and key, right? We have to do the recognition. A very specific substance, molecule is coming, and the cell receptor is seeing this very specific, the one. It's the one. It's seeing the one, and it grabs onto that one and takes it into the cell by way of the phospholipid bilayer. Goes through the phospholipid bilayer by active transport, right? The energy is the ATP that comes and grabs that portion while it's still in between the two hydrophobic tails, grabs it while it's still there, kicks off that energy, boosts the thing, lets that wonderful divine V1 molecule that the receptor took on, and brings it right down into the cell, and then starts this cascading of events, which is the conversation that was between two, right? And now becomes others, many, working together to have this discussion. So we're going to see that in action. We're going to get to know who does what, why they're important or vital to the signaling pathway, and then we're going to actually start talking about pathways. So I am looking forward to. Okay, so just to make sure that we're clear, because I know I said I likened the signal transductions to a conversation started between two people, and then starts to include other people for this collaboration. The process of cell signaling transduction, is going to be a chemical and or physical interaction. All right, so like the physical aspect is the molecule that is recognized by the receptor, and that's the physical thing. Very much like as I found the one type thing. That's physical, right? And then that physical interaction then signals the chemical interaction that takes place after recognition, the active transport. Now, the active transport acts to start this biochemical signaling cascade that starts bringing all these other features, all these other molecules, all these other biochemical signals into place. So back that up, right? So the cascading that happens is going to come about from the proteins. Remember second video, third video, the first video I talked to you about the phospholipid bilayer, and I talked to you about the proteins in the phospholipid bilayer. Then we had the image when we had the designer draw us our phospholipid bilayer. Then after that we had the video. But in the first, we had the image of our bilayer, and we had the proteins laid out throughout that bilayer. You can go to the video prior. So here's the image of the phospholipid bilayer from our cell membrane video, and you can see all the proteins. So the globular protein is going to be our G protein, and this is what I'm giving the example about. But again, you could always go back to the cell membrane video and you'll see it there laid out nice and slow. But this is just to remind you of all the proteins that are on the bilayer. Or I can see if I can get a picture in for you just to remind you. And So protein similar to the G protein. We talked about last video about the different carrier protein. We talked about different proteins in that first video. You can watch that over just to make sure that you're good on the different types of proteins that lie throughout the cell membrane. Well, the G protein is going to be there, and like the G protein, so I'll stay with the G protein. The G protein will be there, just for instance, just for this sake of understanding some of the wonderfulness, the dynamicness, how the cascading happens. So it'll take a protein, and you'll have this protein. The protein will get a it's called phosphorylation. Okay, so it's not. It's phosphorylation. I apologize. I didn't want you to be confused. It's phosphorylation. Phosphorylation. The protein gets a phosphate group added to it, and that can activate or deactivate something in the cell to get a message across. So it really simply put, signaling transduction is going to be talking about the ways in which proteins get phosphate groups added to them and the way in which they respond to the phosphorylation of this, and how they get deactivated or they get activated, and then what that means for the next portion of the conversation. And then that next portion of the conversation, the biochemical signaling, then takes on another route, and there's the different ways that the cascades can go based upon activation and deactivation. And that's simply put the signaling transduction pathways. And of course, there's more to it. We're going to get into that. But this is just a piece of simplified of what it's about. And you will see the wide-reaching effects of signaling transduction as we talk about the maladies and how it can go awry and what it means when certain things are not present and are present. It could be something that's just minor, or it could be a pathological thing. But we're going to get into all of that very shortly. All right. To bringing this wonderful cartoon to you guys, just to let you know I hadn't forgotten about you, because you know, one a week. So I'm working on it. I realized, oh my gosh, I never told them what's going on. I didn't want you to think that I left or forgot. Never. I'm working on our goal. So I look forward to seeing you all next week, and be well.